The wrench slipped from Roy Patterson's hand and clattered across the metal floor of the repair bay. He wiped sweat from his forehead and stared at the small cooling unit he had been fixing for the past 2 hours. Delta 7 station never had enough working equipment, and everything seemed to break at once. A loud alarm echoed through the corridors. Roy looked up as red warning lights started flashing. Emergency docking protocols only activated for serious problems. He grabbed his toolbox and headed toward the main bay. The sight that greeted him made Roy stop in his tracks. A cargo ship 3 times larger than anything he had seen in months was limping through the docking ring. Sparks flew from its engines in bright orange bursts. Purple energy crackled along the hull like lightning. The ship barely made it through the bay doors before its engines died completely. Station workers ran in every direction. Roy spotted Captain Quillies, the Fresnelian station commander, waving her webbed hands frantically at the docking crew. Her amphibian skin had turned a worried shade of dark blue. "Clear the secondary bays," Quillies shouted. "Get medical teams ready." Roy joined the crowd gathering at a safe distance. The massive ship settled onto the docking platform with a groan of stressed metal. Steam and coolant poured from ruptures along its sides. Through the viewport, Roy could see tall reptilian figures moving around inside. "That's a Caldrine merchant vessel," someone next to Roy whispered. "What's it doing out here?" An access ramp extended from the ship. A tall figure emerged, standing at least 7 feet high. Green scales covered his body, and he wore a formal captain's uniform with gold trim. His eyes scanned the crowd with obvious distress. "I am Captain Voren of the merchant ship Stormbreaker," the Caldrine announced in a deep voice. "We carry critical medical supplies for 3 colony worlds. Our fusion drive has failed. We need immediate repairs." Quillies stepped forward. "We will help however we can, Captain. Let me call our engineering teams." Over the next hour, Roy watched as 5 different engineering crews entered the Stormbreaker. Each team stayed inside for 20 or 30 minutes before emerging with the same message: impossible to repair. Critical components destroyed. No replacement parts available this far from the core worlds. A Tritelian engineer named Nasir was the last to exit. His insectoid body moved on 4 legs while his 4 arms gestured at a holographic display. His compound eyes reflected the red failure indicators covering the screen. "The fusion lattice is completely shattered," Nasir explained to Captain Voren. "The crystalline matrix cannot be replicated without specialized manufacturing facilities. These only exist on the Tritelian homeworld. I am sorry, but your ship cannot be repaired here." Captain Voren's scales seemed to darken. Those medical supplies must reach the colonies within 72 hours. Without them, thousands will die from the plague outbreak. "Then you need to transfer the cargo to another ship," Nasir said gently. "There are no ships large enough in this sector," Voren replied, "and no time to wait for one to arrive." Roy found himself walking toward the group before he realized what he was doing. Quillies noticed him first. "Roy, this is not a good time," she said. "I might be able to help," Roy said. Nasir turned his compound eyes toward the human. "Are you an engineer?" "Mechanic," Roy answered. "I fix things that break." "With respect, human, this is far beyond simple mechanical repair," Nasir said. "The fusion drive requires precision components manufactured to tolerances of 1 nanometer. The technology is beyond your species' current capabilities." Roy shrugged. "Can I at least look at it?" Captain Voren studied the human for a long moment. "All the experts have declared my ship dead. What harm can one more opinion cause?" He gestured toward the access ramp. "Follow me." The inside of the Stormbreaker impressed Roy with its size. Corridors stretched in every direction, each one tall enough for the Caldrine crew to walk comfortably. Everything looked advanced and well-maintained, except for the emergency lighting that flickered throughout the ship. They descended 3 levels to reach the engine room. Roy stepped through the doorway and stopped. The chamber was enormous, rising at least 50 feet high. In the center stood what remained of the fusion core. Crystalline structures that looked like geometric sculptures lay shattered across the floor. The one still standing glowed with a dim blue light, pulsing weakly. Conduits and cables hung loose from the ceiling, sparking occasionally. The air smelled like ozone and burned metal. "This is the fusion lattice," Nasser explained, pulling up a holographic schematic. "It creates a controlled magnetic field to contain the fusion reaction. Without the crystalline matrix, the containment fails. The reaction cannot be sustained." Roy walked around the broken crystals, examining them from different angles. He pulled out a small flashlight and peered into the damaged mechanisms. "What was it supposed to do?" Roy asked. Nasir blinked his compound eyes in confusion. "I just explained the function." "No, I mean, what does the ship need?" Roy clarified. "It needs to get to the next major station, right? How far is that?" "The nearest shipyard capable of full repairs is 6 days away at normal cruise speed," Captain Voran said. "And how fast can this ship go with a damaged drive?" Nasir consulted his display. "If we could achieve even 40% power output, we could make the journey in 8 days. But that is impossible with this level of damage." Roy nodded slowly. 40%, that's not so bad." "You misunderstand," Nasir said. "We cannot achieve any power output. The fusion lattice is destroyed." "The lattice is destroyed," Roy agreed. "But what about the rest of it?" He pointed at various systems around the engine room. "What are all those for?" "Secondary systems, backup power distribution, safety mechanisms," Nasir listed. "They are designed to support the primary fusion reaction, not replace it." "Designed for sure," Roy said, "but what can they actually do?" Captain Voran exchanged a glance with Nasir. Neither seemed to understand where the human was going with his questions. Roy pulled off his jacket and rolled up his sleeves. "I need to get inside the core. Can you shut down the remaining power?" "That will take approximately 1 hour," Nasir said. "Good. While we wait, I need you to explain every system in this room. Not what it's designed for, what it can actually do." Nasir hesitated, then began pulling up technical specifications. Captain Voran watched the human with a mixture of skepticism and desperate hope. 3 hours later, Roy emerged from the access tunnel leading into the fusion core. Blue coolant dripped from his hair and coveralls. Grease smudged his face and hands. He was smiling slightly. "I need duct tape," Roy announced. "Also, about 50 meters of spare power conduit and someone's lunch if they're not eating it." The alien stared at him in complete silence. Nasir held the roll of adhesive tape between 2 of his 4 hands, examining it as if it might explode. The Tritelian engineer's compound eyes shifted from the tape to Roy and back again. "You want to repair a fusion drive with this?" Nasir asked slowly. Roy was already pulling cables from his toolbox. "Not repair it, make it work differently." Captain Voran paced back and forth across the engine room, his tail swishing in agitation. "Explain what you intend to do, human. My ship represents 40 years of service. I will not let you destroy it with reckless experimentation." "Fair enough." Roy pointed at the shattered crystalline lattice. "That thing created a precise magnetic field to hold the fusion reaction in place, right?" "Correct," Nasir confirmed. "But it doesn't have to be precise," Roy continued. "It just has to hold, like carrying water in a bucket versus carrying it in a fancy crystal glass. Both work, one just looks better." "The containment field must maintain exact specifications," Nasir protested. "Variations of even 0.01% will cause cascade failure." "For a long-term reaction, sure," Roy agreed. "But we're not trying to run this ship for years, just 8 days. He pulled out a small device from his toolbox. "These are magnetic bottle generators. We use them on cargo ships to contain volatile materials. They're crude compared to your crystals, but they work. Captain Voron's eyes widened. You want to replace precision-engineered fusion containment with cargo equipment. 6 of them, actually, positioned around the reaction chamber. Roy was already climbing a ladder to reach the upper conduits. They'll create overlapping fields. Not pretty, but functional. This violates every principle of fusion engineering, Nasir said, his voice rising. The fields will interfere with each other. The reaction will become unstable. Roy paused on the ladder. Will it explode? Well, no, it will simply fail to initiate. Then what's the harm in trying? Nasir opened his mouth, then closed it. He had no answer to that. For the next 6 hours, Roy worked his way through the engine room like a man possessed. He bypassed the destroyed lattice entirely, running new power lines through maintenance conduits the aliens had never considered using for primary systems. When Nasir explained that certain components couldn't handle the heat, Roy wrapped them in thermal blankets from the ship's emergency supplies. Those are rated for human body temperature, Nasir pointed out. Fusion reactions operate at millions of degrees. The blankets aren't touching the reaction, Roy explained patiently. They're insulating the conduits carrying heat away from it. Different problem. A young Caldrine engineer named Pellies watched Roy work with fascination. Why do you try solutions that should not work? Roy tightened a connection before answering. Because sometimes should not work just means nobody's tried it yet. On the colony world where I grew up, we had one ship that brought supplies twice a year. If something broke between visits, we had to fix it ourselves or do without. You learn to make things work with what you have. But your repairs are temporary, Pellies observed. They will fail eventually. Everything fails eventually, Roy said. The question is whether it fails before or after you're done needing it. By hour 8, Roy had rerouted the ship's coolant system through 3 different auxiliary loops. Nasir followed him with a holographic display, documenting every modification. The Tritellian's scientific curiosity was gradually overcoming his horror at the unorthodox methods. You are using the life support distribution network as a secondary coolant line, Nasir noted. It pumps liquid through pipes, Roy said. That's all coolant systems do. The life support just pumps different liquid to different places. But if it fails, the crew will lose environmental control. If the fusion drive fails, the crew loses everything, Roy pointed out. Priority of problems. Captain Voron entered the engine room carrying a tray of food. He set it down near Roy's workspace. You have been working without rest. Eat something. Roy gratefully grabbed what looked like a protein bar. Thanks. How's the crew holding up? Nervous, Voron admitted. Half believe you are performing a miracle. The other half expect you to destroy the ship. What do you believe? The Caldrine captain was quiet for a moment. I believe you are the only one who looked at my dead ship and saw possibilities instead of problems. That counts for something. As Roy ate, Nasir pulled up a new concern on his display. The pressure regulators for the magnetic bottles will not interface with the Caldrine power systems. The voltage requirements are completely incompatible. Roy studied the schematic while chewing. What about the emergency battery banks? Those provide power for life support during emergencies. How many do you have? Nasir checked his records. 47 distributed throughout the ship. We only need life support in the crew sections, Roy said. How many batteries are in cargo areas or unused sections? Understanding dawned in Nasir's eyes. Approximately 30. There's your power source. We wire the magnetic bottles to run off the emergency batteries. When they drain, we swap in fresh ones. That means crew members will need to change batteries every few hours, Pellies said. For 8 days. Roy shrugged. Better than sitting dead in space. The modifications continued into the night cycle. Station personnel came and went, watching the human mechanic work with a mixture of skepticism and hope. Captain Quillies checked in regularly, bringing reports from the colony worlds. The plague was spreading faster than expected. They had perhaps 60 hours left. Finally, Roy climbed down from the fusion core for the last time. His coveralls were covered in grease, coolant, and adhesive residue. He looked exhausted but satisfied. "All right," he announced. "I think we're ready to test it." The engine room fell silent. Nasir's hands trembled slightly as he pulled up the activation protocols on his display. "If this fails catastrophically, the explosion could destroy the station," Nasir warned. Roy nodded. "That's why I need everyone except essential personnel to evacuate to the far docking rings. Captain Voran, that includes you." "This is my ship," Voran said firmly. "I stay." "Then you get to push the button," Roy said, gesturing at the main control panel. Nasir began the evacuation while Roy made final adjustments. Pellies hesitated at the door. "What made you think this would work?" the young engineer asked. Roy smiled tiredly. "I didn't think it would work, I thought it might work. That's good enough to try." Emergency lights cast long shadows across the empty corridors of Delta 7 station. In the main observation deck, 300 personnel crowded against the reinforced windows, watching the stormbreaker through the transparent aluminum. Some held recording devices. Others simply stared in silence. Inside the cargo ship's engine room, Roy checked his connections one final time. Sweat dripped down his back despite the cool air. He had installed hundreds of improvised repairs in his career, but none with stakes this high. Captain Voran stood at the main control panel, his scaled hand hovering over the activation switch. Nasir monitored a dozen different displays simultaneously, all four of his hands moving across holographic interfaces. "Power levels are stable," Nasir reported. "Coolant flow is within acceptable parameters. Magnetic bottle generators are online and synchronized." "More or less synchronized," Roy corrected. "They're going to wobble a bit, that's normal." "Wobbling magnetic fields containing a fusion reaction is not normal," Nasir muttered, but he didn't argue further. Roy moved to stand next to Voran. "When you activate it, the reaction will take about 30 seconds to build. You'll see the magnetic bottles stabilize first, then fusion ignition, then the power output will climb gradually." "And if something goes wrong?" Voran asked quietly. "Then we'll have about 10 seconds to shut it down before things get exciting," Roy admitted. "But I don't think it will go wrong. The math works. The connections are solid. It should hold." "Should," Voran repeated. "I grew up on a farm," Roy said. "My dad used to say that farming is just controlled chaos. You plant seeds and hope they grow. You fix machines and hope they run. Everything is should and probably and if we're lucky. But you do it anyway because the alternative is giving up." Voran's eyes met Roy's. Something passed between them, an understanding that transcended their different species. They were both people who did what needed to be done, regardless of the odds. "Initiate startup sequence," Voran commanded. His hand pressed the activation switch. Deep within the fusion core, magnetic fields began to form. Roy watched the displays as 6 separate bottle generators created their overlapping containment zones. The fields flickered and wavered, exactly as he had predicted. For a moment, they seemed ready to collapse entirely. Then they stabilized, settling into a rough but functional sphere. "Magnetic containment established," Nasir announced, surprise clear in his voice. "Initiating fusion ignition." Deuterium fuel began flowing into the reaction chamber. Temperature readings started climbing. 1,000 degrees, 10,000, 100,000. An alarm blared suddenly. Roy's heart jumped into his throat. "Pressure spike in coolant line 7, Nasir called out, "exceeding safety limits." Roy was already moving. He grabbed a manual valve near the floor and cranked it hard to the right. The alarm stopped. "What did you do?" Voran demanded. Open the overflow valve, Roy explained, still cranking. Let's excess pressure vent into the secondary loop. It's fine. That valve is for emergency use only, Nasir protested. This is an emergency, Roy pointed out reasonably. The fusion reaction continued to build. Temperature readings passed 1,000,000 degrees. The magnetic bottles held, though they pulsed and flexed in ways that made Nasir's compound eyes widen with each fluctuation. Power output at 10%, Nasir reported. 15%, 20%. Roy watched the core through a shielded observation port. The reaction glowed like a miniature star, blue-white light pulsing with energy. It was crude and unstable compared to a properly functioning fusion drive, but it was working. 30%, Nasir continued. 35, 40%. Output is holding steady at 42% of normal capacity. For a long moment, nobody spoke. The hum of the fusion drive filled the engine room, a sound the Stormbreaker had not made in 3 days. Captain Voran let out a breath he hadn't realized he was holding. By the ancient stars, you actually did it. Roy allowed himself a small smile. Told you it might work. Cheers erupted from the station observation deck. Through the ship's external cameras, they could see people celebrating, hugging each other, waving at the Stormbreaker. Nasir was already running diagnostics, his scientific mind cataloging every detail. This is remarkable. The efficiency is terrible, the power fluctuates constantly, and the whole system violates standard safety protocols, but it functions. Welcome to human engineering, Roy said. We specialize in terrible solutions that somehow work. Pellies entered the engine room cautiously, as if afraid the fusion drive might notice him and stop working. The power is really stable. Stable enough, Roy corrected. You'll need to monitor it constantly. Replace the battery packs for the magnetic bottles every 4 hours. Watch the coolant pressure. If anything starts making noise it shouldn't, shut it down immediately. You make it sound like the ship could fail at any moment, Pelly said nervously. It could, Roy admitted, but it probably won't. The key is paying attention and fixing small problems before they become big ones. Captain Voran stepped away from the control panel, leaving it in Nasir's capable hands. Come with us, human. I want you aboard for the journey to the shipyard. Roy blinked in surprise. What? These repairs are your creation, Voran explained. Only you fully understand how to maintain them. I will pay standard consultant rates plus hazard compensation. I'm not an engineer or a consultant, Roy protested. I'm just a mechanic. You are the mechanic who saved my ship and possibly thousands of lives, Voran said firmly. That makes you exactly the consultant I need. Nasir looked up from his displays. I must agree with the captain. I have documented your procedures, but understanding why they work requires more study. Having you available to answer questions would be invaluable. Plus, Pellies added quietly, it would be good to learn from you. Our engineering focuses on building things correctly from the start. You know how to fix things when they break. That is different knowledge. Roy looked around the engine room at his improvised repairs. Cables ran in ways no designer had ever intended. Systems connected to other systems through pathways that made no sense on paper but worked in practice. It was messy and inelegant and completely functional. All right, Roy agreed, but I need to grab my tools from the station first. The Stormbreaker pulled away from Delta 7 station with a grace that surprised everyone watching. The fusion drive hummed steadily at 42% power, pushing the massive cargo ship forward into the darkness of space. Roy stood in the observation lounge, watching the station grow smaller behind them. Strange feeling, isn't it? Captain Voran said, joining him at the window. Leaving a place knowing you changed it forever. Roy glanced at the Caldrine captain. I just fixed your ship. You did more than that, Voran replied. Word of this repair is already spreading through the communication networks. Every engineer at that station witnessed something they thought impossible. You changed how they think about problems. Before Roy could respond, an alarm chimed softly. Not the screaming emergency alerts from before, but a steady warning tone. Voron's communicator buzzed. "Captain, we have a plasma conduit rupture on Deck 9, Pelly's reported. Coolant is venting into the corridor." Voron's face showed concern. That section was not damaged before. "Probably a stress failure," Roy said, already heading for the door. "The new power distribution puts pressure on systems that weren't designed for it. Where's Deck 9? 10 minutes later, Roy stood in front of the ruptured conduit. Blue coolant sprayed from a crack in the metal pipe, hissing as it vaporized against the hot corridor walls. 3 Caldrine crew members stood back, waiting for orders. Nasir arrived with a repair kit. "Standard procedure requires us to replace the entire conduit section. That will take 6 hours and require shutting down power to this deck." "Or," Roy said, pulling out a roll of flexible polymer sheeting from his bag, "we can patch it in 10 minutes. "That material is not rated for plasma conduit pressures," Nasir objected. Roy was already cutting a section of the polymer. "It doesn't need to hold forever, just 8 days, remember." He wrapped the material around the pipe and activated the quick seal adhesive. Within seconds, the polymer hardened into a solid coating. The coolant spray stopped. Nasir scanned the repair with his instruments. "Pressure is holding. Temperature is within limits. It should not work, but it does." "You keep saying that," Roy noted with amusement. Over the next 2 days, small problems kept appearing throughout the ship. A power relay overloaded. A heat exchanger developed a leak. A magnetic bottle generator began vibrating excessively. Each time, Roy found creative solutions that horrified and amazed the Caldrine crew in equal measure. He fixed the power relay by splitting its load across 2 smaller relays meant for lighting circuits. He stopped the heat exchanger leak with sealant borrowed from the galley's food preservation system. He solved the vibrating generator by wedging it in place with folded thermal blankets. Pelly's followed Roy everywhere, taking notes and asking endless questions. "Why do you always look for the simplest solution first?" the young engineer asked while Roy repaired a stuck valve using nothing but lubricant and patience. "Because complex solutions have more parts that can break," Roy explained. "Simple is reliable, simple is fixable, simple gets you home." "But simple is not elegant," Pelly's observed. "No," Roy agreed, "but elegant doesn't matter if it doesn't work." On the 3rd day, Nasir invited Roy to the ship's technical library. The Tritelian had been spending every spare moment analyzing the fusion drive modifications. "I am writing a paper about your repair methods," Nasir explained, gesturing at holographic documents floating in the air. "But I am struggling to explain the underlying principles." Roy looked at the complex equations and diagrams covering Nasir's work. "That's because there aren't any underlying principles, not the kind you're looking for." "All engineering has principles," Nasir insisted. "Mathematical foundations, physical laws, tested procedures." "Sure, for building new things," Roy said, "but fixing broken things is different. You have to work with what exists, not what should exist." He pointed at one of Nasir's diagrams. "See, you're trying to explain why the magnetic bottles work together, but I didn't calculate that. I just tried it and adjusted until it worked." Nasir's compound eyes blinked rapidly. "Trial and error, that is your method." "Educated trial and error," Roy corrected. "I understand the systems well enough to make good guesses. Then I test them. If something doesn't work, I try something else. Eventually, I find something that does work." "But that could take forever," Nasir protested. "Only if you're trying to find the perfect solution," Roy said. "I'm just trying to find a working solution. Big difference." The Tritelian was quiet for a long time, processing this. Finally, he spoke again. Your species' approach to engineering is fundamentally different from ours. We seek to understand everything before we build. You build, observe, and adjust. Both ways work, Roy said. Yours makes better ships from the start. Mine keeps those ships running when they break in unexpected ways. Perhaps, Nasir mused, the ideal approach combines both methods. An idea seemed to occur to him. He pulled up a star chart. There is a Tritelian research vessel 3 days from here. They are studying stellar phenomena in this sector. I could arrange for them to meet us. Why? Roy asked. Because they have been dealing with equipment failures for months, Nasir explained. Standard repair procedures have not worked. Their mission is in jeopardy, but perhaps a human mechanic could help them see solutions they have missed. Roy considered this. I'm supposed to be monitoring your fusion drive. Pellies can do that, Nasir said quickly. He has learned your methods well. And the research vessel's problems might provide valuable data for my paper. You mean valuable data for understanding how humans think differently about repairs, Roy said with a knowing smile. Nasir's mandibles clicked in what Roy had learned was the Tritelian equivalent of an embarrassed laugh. That too. Captain Voran approved the detour. 3 days later, the Stormbreaker rendezvoused with the research vessel's scientific purpose. Roy transferred over with Nasir, carrying his toolbox and a growing reputation. The Tritelian research crew greeted them with desperate hope. Their lead scientist, a crystalline being named Toles, showed them the malfunctioning equipment. Our analysis suggests the problems are unsolvable with available resources, Toles explained. Roy examined the broken machines. Then he smiled. Let me tell you about the difference between unsolvable and unfixed. The scientific purpose was unlike any ship Roy had seen before. Where the Stormbreaker was built for cargo and durability, the research vessel was all sensors and laboratories. Delicate instruments lined every corridor. Massive telescope arrays extended from the hull like mechanical flower petals. And half of it was broken. Toles led Roy through the main science bay. The crystalline being's body refracted light in rainbow patterns as she moved, creating shifting colors on the walls. Her voice resonated with harmonics that made it sound like multiple people speaking at once. Our primary sensor array failed 6 weeks ago, Toles explained. Then the backup array, then the tertiary systems. We have tried replacing components, recalibrating interfaces, and rebuilding entire subsystems. Nothing works. Roy knelt beside an open panel, examining the equipment inside. Complex crystalline circuits glowed faintly, connected by optical fibers thinner than human hair. Everything looked pristine and perfectly maintained. Tell me about the failures, Roy said. Exact sequence. Toles pulled up logs on a holographic display. First, sensor cluster 7 reported inconsistent readings. We replaced it. Then cluster 9 failed. We replaced that too. By the 4th failure, we realized replacement was not solving the problem. Because it wasn't a sensor problem, Roy said slowly, an idea forming. It was a power problem, or a signal problem, something affecting all the sensors, not individual units. We tested power distribution extensively, Toles said. All readings are within normal parameters. Normal for what the ship was designed to do, Roy said. But what are you actually doing with it? A Tritelian researcher named Felon spoke up. We have been studying gravitic anomalies near the neutron star in this system. The measurements require running all sensor arrays simultaneously at maximum sensitivity. Roy looked at Nasir. Were the sensors designed to run all at once? Nasir consulted the ship's technical specifications. They were designed for sequential operation. Running multiple arrays simultaneously for extended periods was not part of the original design parameters. There's your problem, Roy said. You're drawing more power than the system was built to provide. It works for a while, Then something overheats or overloads and fails. But we monitored power consumption, Felon protested. We stayed within rated capacity. Rated capacity assumes normal cooling and normal operation cycles, Roy explained. You're running everything hot and continuous. That changes the math. He pointed at the power conduits. These carry electricity through optical pathways, right? Light instead of copper wire. Correct, Toles confirmed. Light generates heat when it's concentrated, Roy said. In normal operation, the system has time to cool between uses, but running continuously, the heat builds up. Eventually, it damages the optical pathways. Then the solution is to add more cooling, Felon suggested. Or reduce power draw, Roy countered. Do you need all the sensors running at full power all the time? Toles considered this. Our research protocol calls for comprehensive data collection. But do you need it? Roy pressed. What if you rotated which sensors run at full power, give each array time to cool while others are working? The researchers exchanged glances. Felon spoke hesitantly. That would reduce our data collection efficiency by approximately 40%. But it would let you actually collect data instead of watching your equipment break, Roy pointed out. 40% of something beats 100% of nothing. Toles made a sound like wind chimes. Roy learned this meant she was thinking deeply. The human raises a valid point. We have been so focused on maintaining our ideal research parameters that we failed to adapt to the reality of our situation. Over the next several hours, Roy helped the research crew reorganize their sensor operations. He showed them how to stagger power usage, build in cooling periods, and monitor heat accumulation. He also fixed 3 other problems they had assumed were unfixable. A navigation computer that kept crashing was actually running out of memory because nobody had cleared its cache in months. Roy showed them how to set up automatic cleanup routines. A water recycling system that produced contaminated water was suffering from clogged filters. The crew had been replacing the filters, but Roy noticed they weren't cleaning the pre-filter screens. Months of accumulated residue was forcing contaminants past the main filters. A communications array that couldn't maintain stable connections was positioned too close to the ship's main power conduits. Roy suggested moving it 3 meters to the left. The interference disappeared. You solve problems so quickly, Felon observed. How? Roy cleaned his hands on a rag. I start by asking what changed. Things don't usually break randomly. Something caused it. Find what changed, you often find the problem. But we document all changes, Felon said. We follow strict modification protocols. What about things that changed naturally? Roy asked. Dust buildup, wear and tear, heat accumulation over time, systems shifting slightly from vibration. Those aren't in your logs, but they still affect how equipment works. The concept seemed to fascinate the researchers. Nasir was frantically documenting everything, his 4 hands moving across multiple displays simultaneously. By the time Roy returned to the Stormbreaker, the scientific purpose had all its sensors operational again. Toles thanked him with a crystalline sculpture she had created, capturing his image in refracted light. You have taught us to see our equipment differently, Toles said. Not as static systems, but as dynamic entities that adapt to use and time. Captain Voren welcomed Roy back aboard with obvious relief. I was beginning to worry you would decide to stay with the research vessel. They don't need me full time, Roy said. They just needed to learn to think about problems differently. Felon's already picking it up fast. That seems to be your real skill, Voren observed. Not fixing things, but teaching others to fix things. Roy hadn't thought of it that way before. He looked around the Stormbreaker's bridge, where Pellies was confidently monitoring the fusion drive, making minor adjustments without hesitation. Maybe, Roy admitted, though I still think of myself as just a mechanic. Words matter less than actions, Voren said. And your actions are changing how people throughout this sector think about engineering. A message arrived from Delta 7 Station. Captain Quillies reported that 3 more ships with supposedly unfixable problems had requested human mechanics to examine them. Apparently, the story of the Stormbreaker's impossible repair had spread faster than the ship itself was traveling. You have started something, Nasir said, reading the same message. A shift in perspective. Roy looked at the stars ahead. Somewhere out there, ships were breaking down. Engineers were declaring repairs impossible. And now, humans were being called in to find the solutions everyone else had missed. It felt good, not because it proved humans were better, but because it proved different perspectives working together could solve more problems than any single approach alone. 3 months after the impossible repair, Roy stood in a training facility on Delta 7 Station that hadn't existed before. 12 workbenches filled the space, each with deliberately broken equipment waiting to be fixed. Students from 6 different species worked at the benches, struggling with the tools and concepts. No, no, Roy called to a young Fresnelian trying to replace an entire circuit board. You don't need to replace it. Just bypass the burned section and reroute through the auxiliary pathway. But the manual says to replace damaged components, the student protested. The manual assumes you have replacement parts, Roy countered. What if you don't? What if you're 3 weeks from the nearest supply depot? Then what? The student hesitated, then started examining the circuit board more carefully, looking for alternate pathways. Captain Quillies watched from the observation window above. Nasir stood beside her, reviewing the curriculum they had developed together. The Galactic Engineering Council has approved our certification program, Nasir said. Students who complete this training will receive credentials in adaptive repair methodology. Humans call it making do with what you've got, Quillies noted with amusement. The terminology is less important than the concept, Nasir replied. We are teaching a skill that most species have never formalized, the ability to solve problems with limited resources and imperfect conditions. Down in the training bay, Roy moved between workstations, offering guidance. At one bench, Pellies was teaching 2 other students his own experiences from the Stormbreaker. The key is understanding the difference between optimal function and adequate function, Pellies explained. Roy taught me that a repair doesn't need to be perfect. It needs to work long enough to get you somewhere you can make it perfect. A message alert interrupted the training session. Roy checked his communicator and smiled. Captain Voren's face appeared on the screen. The shipyard engineers have examined my vessel, Voren reported. They were amazed that your repairs held for the entire journey. Some want to preserve sections of the fusion drive as examples of innovative engineering. How's the ship running now? Roy asked. Perfectly. They replaced everything you modified with proper components. Voren paused. It runs exactly as well as it did before, but without the character your repairs gave it. The chief engineer said he was almost sad to remove your work. He called it a masterpiece of creative problem-solving. Tell him he can break something if he wants another masterpiece, Roy joked. After the call ended, Roy returned to his students. A Tritelian named Sylvan was struggling with a broken pump. I cannot make it work, Sylvan admitted. The impeller is cracked. Without a replacement, the pump cannot function. Roy examined the crack. Does it need to pump at full capacity? The specifications call for 50 liters per minute. I asked if it needs to, not if it's supposed to, Roy clarified. What's the actual minimum flow rate for the system this pump serves? Sylvan consulted the technical documents. 20 liters per minute would be sufficient for basic operation. And can this cracked impeller move 20 liters? Sylvan tested it carefully. Yes, at reduced speed, but operating damaged equipment is against safety protocols. Operating damaged equipment without monitoring is against safety protocols, Roy corrected. If you check it regularly and replace it when the crack worsens, you can use it until you get a proper replacement. That's the difference between stupid risk and calculated risk. Understanding lit up Sylvan's eyes. I see. We are not ignoring the problem. We are managing it. Exactly. The training program had grown beyond Roy's expectations. What started as an informal workshop had evolved into a recognized educational institution. Engineers from across the sector enrolled in courses. Some came curious. Others came desperate, having dealt with unfixable problems in remote locations. Toles from the Scientific Purpose even developed a specialized course in sensor management, using lessons learned from her ship's repairs. She taught students how to adapt research equipment to work within power limitations. News of the program spread. Other stations requested permission to establish similar training facilities. Human mechanics who had spent years working on frontier colonies suddenly found themselves recruited as instructors. The galaxy was learning that the skills humanity developed from necessity had value beyond simple survival. One afternoon, a delegation from the Tritelian Science Council arrived at Delta 7. They wanted to observe the training program and potentially incorporate its methods into their own educational systems. The lead counselor, an elderly Tritelian named Hers, watched Roy work with students for several hours. Finally, he approached. I have spent 60 years in engineering, Hers said. Your methods contradict everything I was taught, yet they work. This troubles me. Why? Roy asked. Because it suggests we have been teaching engineering incorrectly for generations. No, Roy said gently. You've been teaching one kind of engineering, building new things that work perfectly from the start. That's important. But there's another kind of engineering, fixing old things that break in unexpected ways. Both matter. Hers's mandibles clicked thoughtfully. You are saying our approach was incomplete, not wrong. Right, and our approach is incomplete too. Humans are great at improvising repairs, but we're not so great at building things that don't break in the first place. Working together, combining both approaches, we can do better than either species alone. The concept seemed to resonate with Hers. He authorized funding for 10 more training facilities across Tritelian space. That evening, Roy sat with Nasir, Pellies, and Captain Quillies in the station's observation lounge. Through the windows, they watched ships come and go, carrying goods and people across the vast distances of space. Do you ever regret it? Nasir asked. You could have stayed a simple station mechanic. Instead, you became a teacher and inadvertently changed galactic engineering culture. Roy thought about his daughter on the colony world, about the medical supplies that had arrived in time to stop the plague, about all the students learning to see problems as opportunities rather than obstacles. No regrets, Roy said. I just fixed a ship because it needed fixing. Everything else grew from that. That is your species in summary, Quillies observed. You see something broken and your instinct is to fix it, not because someone ordered you to, not because it's your job, just because it needs doing. Humans don't think of ourselves as special, Roy said. We just do what seems obvious in the moment. That, Nasir said, pulling up data on his display, is what makes you special. You have democratized innovation. Every human seems to believe they can solve problems, regardless of formal training or credentials. You try things because they might work. Most species need permission or extensive analysis before attempting anything new. A new ship appeared in the docking pattern, its distress beacon flashing. The message came through quickly. Xantharian vessel, power system failure, all standard repair attempts unsuccessful. Roy checked his schedule. He had 3 hours before his next class. Want to come see what's broken? He asked Pellies. The young Caldrine engineer grinned. Always. They headed to the docking bay together, teacher and student, human and alien, both eager to find out what impossible problem they could solve today. Behind them, the training facility hummed with activity. Students learned, perspectives shifted, and the galaxy slowly discovered that sometimes the best way forward was combining the precision of planning with the creativity of adaptation. Roy grabbed his toolbox, the same battered case he had carried for years. Inside were simple tools, wrenches and screwdrivers, duct tape and wire, nothing fancy or advanced, just enough to fix what was broken and help what was working work a little better. Which he reflected, was all engineering really needed to be.